In this video, we're going to determine the values of sine theta and the sine of theta over 2 when given certain information about cos squared theta. So we're told that the cos squared of theta is 7 over 16, and we're told from here that theta is in the second quadrant. Okay? Because theta is in the second quadrant, we know that sine theta will be positive, and we know that cos theta will be negative, and if we need to find tan theta, it'll be negative. Okay? So, we know that cos squared theta is 7 over 16. Well, cos squared theta equals 7 over 16 implies that cos theta is equal to negative the square root of 16, negative the square root of 7 over 16. Again, because we're taking the square root, but we're putting a negative in front because, as mentioned in the last slide, theta is known to be in quadrant 2 where cos will be negative. Well, when you have a square root of a fraction, you can take the square root of the numerator and the square root of the denominator. The square root of 7 can't be simplified, but the square root of 16 sure can. It's 4. And so we know that the cos of theta is equal to negative root 7 over 4. Okay? Now, we're going to need that soon, not quite yet. Right now, though, let's determine the sine of theta because that's one of the things being asked for in the question. We go back to a trig identity that we learned earlier. Sine squared theta plus cos squared theta equals 1. Well, that means that sine squared theta equals 1 minus cos squared theta. Cos squared theta is 7 over 16. It's right in the question. So sine squared theta must be 1 minus 7 over 16, which is 16 over 16 minus 7 over 16, which is 9/16. So that's what sine squared theta equals. So sine theta must be equal to positive the square root of 9 over 16, not negative. Why? Because, again, theta is an angle in quadrant 2 where sine will be positive. Little typo here, there should be a square root over that 16. We get root 9 over root 16, which is 3/4. So sine theta equals 3/4, and we've answered part of our question. Sine theta equals 3/4. Now let's figure out the sine of theta over 2. How do you find the sine of theta over 2? Well, what you do is you get the double angle formula for cos, but you don't use this one because that one doesn't involve sine theta. And you don't use this one because this one here has cos theta and sine theta. Let's use this one instead. Let's use this double angle formula for cos because it only involves sine theta on the right-hand side, and we're being asked to find a sine of half that angle. So this is the version we're going to use. Now, a really good thing about this equation, and this is something that we went over in a lesson, was that we can divide each of those angles by 2. So I can take 2 theta and divide it by 2. So instead of saying cos 2 theta, it'll say cos theta. I can take theta and divide it by 2. So instead of saying 2 sine squared theta, it'll say 2 sine squared theta over 2. I'm allowed to do that based on discussions we had in an earlier video. So we've got cos theta equals 1 minus 2 sine squared theta over 2. Now all I have to do is isolate sine squared theta over 2 and then take a square root and determine whether it should be positive or negative. So given this expression right here, I'm going to say let theta be, we don't have to let theta be anything. We already know the value for the cos of theta. We figured it out earlier in this solution. The cos of theta is negative root 7 over 4. So negative root 7 over 4 is equal to 1 minus 2 sine squared theta over 2. Now I'm going to move this 2 sine squared theta over 2 to the other side and move this negative root 7 over 4 to the other side, adding each of them to both sides. And what I end up with is this expression. 2 sine squared theta over 2 equals 1 plus root 7 over 4. Well, let's evaluate 1 plus root 7 over 4 before we go any further. we got a common denominator here. So instead of saying 1 over 1, we'll say 4 over 4. 4 over 4 plus root 7 over 4 is 4 plus root 7 over 4. So that means, to summarize what's on the left, 2 sine squared theta over 2 is equal to 4 plus root 7 over 4. Well, if I divide both sides by 2, then this 2 is gone, and this 4 becomes an 8. That's what happens when you divide both sides by 2. In other words, multiply both sides by a half. So we're able to say sine squared theta over 2 equals 4 plus root 7 over 8. Now, we have to figure out, should we have positive the square root or negative the square root, because it's pretty obvious that our next step is going to involve square rooting because we've got sine squared and we were just asked for sine. Well, this is where it's a little bit trickier than it looks. The question tells us that pi over 2 is less than theta is less than pi. So a lot of people right now say, okay, therefore I know sine will be positive. You're right, sine's going to be positive, but not for the reason you think. We're being asked for the sine of theta over 2. So we have to know where that angle is. So what we're going to do is we're going to take this inequality right here, and we're going to divide each one of those sides by 2. So pi over 2 divided by 2 becomes pi over 4. Theta divided by 2 is theta over 2. Pi divided by 2 is pi over 2. Now this tells us where theta over 2 is, because that's the angle we're concerned about, because that's the angle we're looking for in the question. Well, pi over 4, for those of you who don't love radians, is 45 degrees, and pi over 2 is 90 degrees. So what that tells me is that this theta over 2 angle that I'm looking at is somewhere in here. Well, when you have a terminal arm in there, the sine of it is positive. So the sine of theta over 2 will be positive, perhaps not exactly for the reason you suspected a minute ago. Okay, so what we're going to do is we're going to take positive the square root of that right-hand side. Okay, so again, this is what we had. Now, I can look to the future and I can see that when I take the square root of 4 plus root 7 over 8, that's ultimately going to equal the square root of 4 plus root 7 over the square root of 8. Well, the square root of 8 is an irrational number. So rather than have an irrational number in the denominator, it's pretty clever if you just multiply the numerator and denominator both by 2. If you do that, then when you go to take your square root of 8 plus 2 root 7 over 16, you end up with the square root of 8 plus 2 root 7 over the square root of 16, and this is not an irrational number. That just equals 4. So that's kind of a nice way of looking ahead and seeing, hey, let's help ourselves rationalize this denominator a bit, make our lives easier. But anyways, getting on with it, we're taking the square root of 8 plus 2 root 7 over 16. That becomes this expression here, as mentioned earlier, which gives us our final answer. Okay.